All right, so first we're going to be hearing from Denver Smith. Thank you for offering to talk about this with us. And then I'll be presenting after this. So go ahead, take it away.
Awesome. I don't know if I'm going to stand up or sit down, but I'll start with standing. My name's Denver. I've been here a few times. I really like this community. And I decided to volunteer for this talk about mocks, which is actually something that I've never used. This is my first time, like preparing for this talk is the first time that I've used this library. And so I wanted to use this opportunity to kind of learn something new. So you guys are all going to suffer because of that. But
it's presentation-driven development.
Yeah. PDD. Mocks. We're going to talk about unit testing and creating mocks with Elixir. And I want this to be kind of like just an open discussion, because like I mentioned, I'm not really an expert on this, and I know there's a lot of really smart people in the room, and so don't hesitate to shout out things that you know or ask questions. And the first question I want to talk about is what is a mock? Does anyone think they can sum it up really well?
It's a stand-in for a real object.
Yeah.
Something.
And by the way, it's one of the things that I find really hard about learning about testing and stuff is all the different terminology that they have. There's there's mocks, there's stubs, there's instance doubles, there's there's all these different words, and I honestly can't really tell you the difference between them, and I don't think it necessarily matters. But this is a definition from Wikipedia about mocks. Mocks are simulated entities that mimic the behavior of real entities in controlled ways. So yeah, just so we're on the same page. And then another question I have is when would you use a mock? Does anyone have an example of when they've used a mock, whether it's in Elixir or not?
Don't want to hit the real API.
Yeah, APIs.
Testing.
Yes. That's pretty much those are the things I can think of too. Say you need to test an external API, or really if you think about unit testing, you only want to test that one unit of your code, and so your code's not always, in fact, pretty much all the time your code is connected somehow, but you need a way to only test the relevant part that you want to focus on. So mocks come in handy for that. And then kind of the same story as external APIs, just database interactions. Things like that can be really expensive time-wise. And so if you have a really big test suite, you don't want all of your tests to hit the database. You want to control that and put that in a isolated part of your application when possible. So yeah. By the way, has anyone used mocks? Oh, nobody. You have? Cool.
Do you mean mocks the library or mocks?
MOX, the library. Okay, yeah. So Jose Valian has a great article. Has anyone read this article?
I'll go get the gang. Sorry, it's not coming.
Oh, okay. Yeah, there's an article online called Mocks and Explicit Contracts. And if you haven't read this article, it's pretty much a prerequisite to using this library, so I would highly recommend it. And I just wanted to kind of highlight some of the points. If you Google, and if you Google this phrase, you'll find it. So part of this article, Jose gives this kind of use case. So let's say we have a controller, and in that controller, we have a show action, and this controller is interacting with a Twitter API somehow, and so you can see my app.twitterclient.get username. So we're basically just getting a username from Twitter, and so let's talk about like some potential pitfalls about how you would go about doing a mock for this. Oh, and, well, yeah. So there's other mock libraries to create mocks in Elixir. I don't really remember the name of them, but I tried to use some other ones as well as mocks in preparation for this. And like this, I think is one of the other libraries. So one way you could like mock this, and notice I'm saying mock as a verb. You could say mock HTTP client get, I want it to return that. And so effectively, you can imagine your Twitter client probably uses the HTTP client to do that request. And so this is one way you could do it, but can anyone think of like maybe some drawbacks to doing something like this? If not, I can explain.
Well, it assumes, so there's a few things, right? It exposes to the tests how it's actually implemented, that it is using HTTP client or something. It also, when you mock like that, it overwrites it globally for the whole application. And since Elixir has asynchronous, you can have concurrent tests running. It will break some tests sometimes, and then if you rerun it again, they're running in a different order, and they'll break different tests sometimes. So then you have to run it so it's not async, and you have to put it back or whatever. But
yeah, totally. That is exactly kind of what I was going to say and where I was going. And in Jose's article, he talks about that, and he talks about how this controller really should not be aware of how the Twitter client works. And the test for this controller is the same way. We don't want to assume that it's going to use the HTTP client because that could change as time goes on, and if it does change, this test is going to fail. In reality, all we care about is that a username comes back and nothing else. So, and then like you mentioned, with Elixir, it's when you change something like that, HTTP client, it can cause random failures because of, and actually I wanted to simulate, I wanted to see if it actually did give me random failures, and it does. I used a different mock library, and I made a little app that's like a blackjack, I don't know, like an app that you play blackjack with. And I wrote some tests knowing, trying to get this to happen, and about like 10 or 20% of the time I would get an error like this. So yeah, it's true. You can imagine how frustrating that would be in the real world. So the big thing with mocks, MOX, the library, is that it's really a small library, but there's a lot of philosophy behind why it is how it is, and it comes down to basically what's the word? Explicit contracts. So if you look at these two approaches to that controller that we were just looking at, the top one well, let's look at the bottom one first. So this is, kind of the not so great example, because my app in the test, really you're saying the application depends on HTTP client, and that depends on the Twitter API. But we don't want that. We want it to be something more like this, where my application, depends on the Twitter API, and that's a specific contract that we've set up a boundary for. And so inside of there, we can depend on the HTTP client because, that's a whole different boundary, and then to the Twitter API. Does that kind of make sense? Yeah, and let me know if there's any questions as I'm going. This is a good quote I liked from the article. A test is a consumer of your API like any other code you write. One of the ideas behind TDD is that tests are no different from code. So I think some people may argue, if I need to structure my application in a way that I can test it, isn't that kind of a bad idea? Because, no one wants to like do something just so a test will pass. But on the other hand, a test is a consumer of your app, just like anyone else. And so I think you'll find that when you design your applications with explicit contracts, it's actually a good practice, and you get a lot of benefits from doing that. And so these are just three things I wanted to mention that I could think of that kind of like benefits that comes from using MOX. So first of all, it embraces existing Elixir language features, and I've got a little demo that I'll show after this slide that we can kind of see these. And then it also allows us to continue running tests in parallel, and then in general it just helps you write nicer code, I think. So yeah, that's all my slides. Let me pull up a little demo and we can walk through it. And yeah, this is what the article looks like. It's on Platform and Tech.
That is a good article. I've used that a lot.
Yeah, and this article was a precursor to the MOX library. So this was actually written before MOX even existed. So okay, so let me tell you what my app is. I've got an application called Naughty Nice List, and this is Santa Claus's Naughty and Nice List. So this is how it works. Let me just go into a console. We've got Naughty Nice List. These are some of the public APIs that we can use. So we've got initialize, we've got add, we've got remove, we've got find status. We can toggle what list they're in. So this is something that Santa Claus would use to keep track of people. Oh, and we've got like print summary, which is like I'll do it. Uh-oh. Oh, I know why. I didn't initialize it first. Okay, so you can see that's kind of what it looks like internally, and then this is what Santa Claus would use for like viewing. It's like the view of it. There's just two columns. So I'm gonna add, let's say, nice. Add myself to the nice list. I'm gonna also add my wife. And I'm gonna add my little brother to the naughty list. And then I'm gonna print the list. Well, I'll pretend like I'm Santa, but printing the list. So you can see it's as expected. So that's kind of the gist of the app that I made to kind of demonstrate this. So let's look at the code. I think I will exit this. Just zoom in. Okay, so this, let me show you the directory real quick. So where's lib? Okay, yeah. We've got lib, we've got this, which has, I like to put the public API right here. And then I've got a folder also called Naughty Nice List, and these are, some kind of internal features of the app. And so this is the public API. So let's just go through this a little bit. Here's the init, and really that just delegates what it actually does down to this thing's store. And so I designed this application so that I could have whatever kind of store, like data store I wanted. So right now it's using agent, like an Elixir agent as the store, but I also made it in such a way I could swap that out with like Redis or, probably like Ecto or something like that. So yeah, these are just some public methods, and the one we're going to focus on is the print summary right here. So we can see we get the names in the nice list, we get the names in the naughty list. We start out with this, which is the header that we're going to print, and then basically I just zip these two lists together. I had to make my own zip because the list could be different lengths. And so that's what it looks like down here, but don't really need to do that. So we zip them together, we map over them and make them into this string. So it has the nice, because I need them to go in the columns. So nice names on the left, naughty names on the right. And I put that through a reduce, and then IO dot puts it. So this is something we need to test. And I wrote a test for this already, so let's look at that.
I love that reduce function for the anonymous function that you're passing it into.
That looks great.
Definitely,
That's cool.
to someone who knows this, it would make perfect sense. Yeah. So we'll start with this summary. This has nothing to do with mocks, but we'll go through it.
Okay.
This is just a string, and I did it multi-line just so I could write it out like this. So I've got two tab separated columns. And then I'm reassigning summary. There's maybe a nicer, more Elixir way to do this, but I don't know. I'm reassigning summary with, first of all, I take my zip fill function. So you know what the zip function does. If you've got two lists, it just combines them together, like one from this list, one from this list, one from this list, one from this list. But like I said, I had to make my own version because a lot of times the lists are going to be separate lengths, and the normal zip function will not care that they're different lengths. It'll just stop. But I need to keep going. So that's basically just a zip. And then enum.map. So what comes back from zip is an array of, what are those called? Tuples. An array of tuples where the left one is the nice name and the right one is the naughty name. And so I'm just pattern matching. I could have just wrote names instead of that, but I'm just going to use pattern matching right there. And then the body of this anonymous function just does some string interpolation. So we put the nice name, two tabs, and then the naughty name. So we're mapping doing that. And then finally reduce, I needed to change the array into a string. And so the starting value is summary, which is that text up there. And then this is a shorthand syntax for an anonymous function, I guess. So this ampersand kind of indicates that, ampersand and then braces or parentheses. And then ampersand 2 is like the second argument, and ampersand 1 is the first argument. So if you remember, you can think of them as nice name, naughty name. And so it combines those together.
Yeah, so assuming they're both strings, and it just concatenates one string to another string, and then concatenates a line feed.
Yeah, so actually, I guess I kind of messed up explaining this. Ampersand 2 is actually
It's the pair of naughty and nice, and one is the summary, so every iteration the summary grows by one line, right?
Right, exactly. And then we just IO dot puts. So that's how this works, and this is, so I want to test this, but if you look at this, this data is coming from my data source, so that could be Redis, that could be an agent, could be anything. Santa is the one using this piece of code. He doesn't actually care how this works, he just cares that this list gets printed. So we're going to want to use a mock to be able to skip over some of these details in our test. And so let me just go to the test. I've actually got two tests. And so I've set up mocks already, but I'll show you the test first and then I'll go through how to set it up. So test, pretty print the list when there are no names. So I made this mock, which I'll show you how to do in a minute. I'm expecting that it receives names with nice as the argument, and it comes back with no names. And I'm also expecting the same thing with naughty. So this is effectively testing when there's no data. And so XUnit, I think, has this capture IO feature module, and this is how you can test like output. So we can assert that capture IO, and then you give it a function, so we just give it the function we're testing, and I'm asserting that it equals this, which is what I would expect for an empty list. So that's how that test looks. And then same thing down here. You can see I set this one up where I have myself and my wife in the nice list, and then my little brother in the naughty list. And the list changes because of that. So the reason we're mocking this is because, sorry, not mocking, mock as a noun. The reason we created a mock for this is because Santa does not care how that part works. So all we need to do is expect that it happens. Yeah, does anyone have any questions so far?
Let's see if I, go ahead. Let's see if I understand. So what we're doing is we are creating a data store that is a mock of what our production data store would be.
Mm-hmm.
And then is it getting passed into your application logic somewhere?
Mm-hmm.
Okay.
Yeah, and so I haven't explained that yet, but that's exactly right. Because we made this mock store. When I was showing you in the console, it was using the agent store. But, so yeah, we could probably move into how that works, because it's a big part of mocks. So, back in our public API, you'll notice up here this line, I'm setting a, what is this called? A module attribute, an attribute called store. And I'm getting it from my application's environment. So you know how you can have like several different environments in your application? You can have like a dev environment, you can have test environment, production environment. So I set up in those files this data store environment variable, which looks like this. Config, let's look at dev. Yeah, so here's my dev config, and you can see it's using agent store. But I also have a test config, which is using mock store. So that's how that kind of piece fits in. Let's see. So yeah, we can get that detail at runtime, because when I'm running my test, I want it to use the test one. If I'm just using it, I just want it to use the agent store. So then what else about that? You might be thinking like, isn't that a lot of work to have basically 3 different versions, or like 2 different versions of the same module? Like, that could get really complicated to manage. But I don't know what I changed in there, but that's where the idea of explicit contracts come in. So let me show you. Has anyone used like behaviors in Elixir? So I'll kind of explain what that is. So I've got my agent store there, my data store, and a Redis store. Let's look at data store, which is actually a behavior. So if you're not familiar with a behavior is basically like, what's a good way to describe it? It's kind of like
abstract class?
Yeah, like an abstract class, because you're defining what your interface to the module should be like using type specs. So you can see I made my own custom type called naughty nice list, which is this representation of the state. So it's got 2 keys. It's got the values are lists of strings, and I hardly ever have done type specs, so maybe I'm doing this wrong, but you get the idea. And so every data store is something that we can give to all the other stores and say, I want, like, you should implement these methods, or sorry, these functions. And Elixir gives you like some static analysis, or what's it called, like like it'll give you warnings if you don't implement those functions. And so, like if we look at Redis, I haven't implemented the functionality for this, but you can see it has the same interface. And so this is how you use the behavior, say behavior data store, so that's how I know this needs to conform to that. Same with agent. So it has this behavior. Yeah, and this one's built out, but. And so this is where if you remember, we had a mock store. So it's not in that directory there in my lib folder, but you can define it. I guess the recommended place to define it is usually in test/support/mocks. And so we can say mocks.defmock, and this is defining a mock called mock store, and it's for our data source. So this is what kind of keeps all of your data stores on the same page, because mock store, it can't be just like anything. It needs to conform to this data store behavior. Does that make sense? Are there any questions right now? I guess you'll notice, like, I haven't really talked much about the actual library mocks. I've talked more about how I've set up my project to accommodate for this kind of. And I think that's kind of a big idea of this library mocks, is they wanted to make a really simple library that just helped enforce this idea that Elixir already has of behaviors and stuff and explicit contracts. So I think that's really cool. If you do like mix compile, this will check. This will force Elixir to check all of your type specs and stuff. So I don't have any errors right now, but if I go, let's see, what could I change? Let's go to the agent store and get rid of init. Actually, I'm just going to comment it out because I don't want to actually delete it. Now I think I'll get it. Yeah, you can see I got a bunch of warnings like, hey, this is unused. So that you can see how that kind of is beneficial. Let's play around with the test kind of to wrap it up. Let's just play around with these tests a little bit. If you go to the mocks library, you can find documentation on what methods they have, but the one you'll probably, sorry, I keep saying method, but what functions they have. But the one you'll probably use the most is expect. So what if we change this and add like a third name? I would expect my test to actually fail now, because if this is what's coming back from the store, the data store, then this list is actually not right. So let's see what happens. And I think if you use -- force when you're running your tests, you'll get warnings every time, whereas sometimes you'll get them once and then they'll go away.
Yep.
So that's why I'm doing that. And yeah, we see it failed now because our capture IO part failed, because it's now not what it is expected to be. And then similarly, if I undo that and just take out this altogether, I would expect this to fail, because in my code, where was that? In my code down here, you can see I'm calling it twice. Nice, I'm calling names with nice, and I'm calling names with naughty. So if I'm only expecting nice, it's going to get to that naughty and freak out. And this is kind of what it'll tell you. Expected blah 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 / names to be called once. So if you've ever used, if you're familiar with like Ruby and RSpec and stuff, it's really similar to those kind of messages it'll give you. But yeah, that's pretty much all I had prepared. Are there any other thoughts or questions?
Thanks.